So let us start today's webinar. And as Julia said, that today's our main focus is to know how you can design an embedded TinyML application using Neuton platform that uh, that has the very practical potential in our world, and how you can use the Neuton TinyML platform to create a real world application that really interact with our world. So this is a very practical use case, and uh, maybe in the coming future you are going to see similar kind of application in our daily life. As we know that the TinyML is growing, and most of the devices that we see around us, most of the electronic devices that we see around us already has a processor or microcontroller built in. So we can say that they had the computing capability. Now the use case is also growing, and devices are becoming intelligent. So uh, that these devices can take decision of themselves. So in that scenario, the TinyML plays an important role. So today I'm going to discuss my use case, a project on which I am working using the Neuton TinyML platform for the smart shipping industry. And this is a very practical use case. So as we have already know, or you might have also aware about it, that the Neuton is a perfect platform to build TinyML applications. And in this session, we are going to learn how we can make the edge devices smarter in a very few steps, which is possible using the Neuton TinyML platform. And Neuton TinyML platform, when you talk about Neuton TinyML platform, so you have to remember three words which are mentioned here, three phrases: build fast, build once, and never compromise. So this is the theme behind the Neuton TinyML platform. And whenever you are building any solution, so you have to keep in mind that using Neuton TinyML platform, you can build fast, build once, and you never compromise, because the TinyML model, the machine learning model that you build using Neuton TinyML platform, can fit almost all resource constrained devices. Okay, so because the model that we build using Neuton TinyML platform is a very small, and uh, you even though the model is very small, very tiny, you never lose accuracy that we require. Okay, so we are going to see how we can do that in today's session. So before I continue, so I have one link about the Neuton platform to show you one video. So then we will continue.
Timothy, I think we don't have sound, but anyway,
Okay,
we saw this video yesterday in the yesterday
sure.
session, so we can skip it, I think, for today and go to the use case.
Okay, sure.
Thank you.
So now I'm going to discuss my solution, my project, which is titled as Smart Shipment. So Smart Shipment is a project which is mainly focused on shipping industry. So we all are very touched with this industry, as in our life, in our everyday life, we usually get shipment from different companies. So we are all aware of this shipping industry, and we are touched with it. So here the smart shipment is the TinyML solution for this shipping industry. Although the solution which I'm going to explain here isn't implemented yet, but in the near future, you are really going to see that uh, this kind of project is working for you. Okay, so the smart shipment is a project for shipping industry. Using this project, any user can track the status of his package or shipment while the package or shipment is in transit. Okay, so this project mainly focuses on how user can track their packages or their shipment while the shipment is in transit. Today also we can track it, but we cannot get the information about the status of your package. Okay, so what do I mean here by a status? So before we begin, let me show you one video. So this video helps you to understand what is the project all about. Okay, so you all have seen this video, and in this video, it is very clear that the user can view the status of his package or shipment while it is in transit. So the different status I have implemented. So I have implemented 5 of them. Stationary means the shipment isn't moving; it is at some warehouse or some other place. And moving status, it means that shipment is carried away. And you have also seen that when the shipment is thrown or whether it is placed uh, in the wrong position, etc. Okay, so these are the kind of status that we can status information about our package or shipment that we can get using this project. So I have implemented only the few of them. So I have implemented moving or stationary, thrown, picked, or placed in wrong position. And you can even implement when the shipment is impacted, whether it has been uh, kicked or not handled carefully. So all those kind of status that you can implement. So it depends upon your imagination. Okay, so you can think of it. So while you will be doing your homework, so you can think of it, what other kind of status also that you can implement. So here, particularly, I have mentioned all of these status, out of which I have already implemented some of them. And in today's session, I'm going to show you how you can implement the status of stationary shipment, moving shipment, as well as the shipment while it is picked. And data set is also will also be provided to you so that you can try. So why it is important, why we need to keep track of our shipment. So there could be many possible reasons. And one of those reasons is that you just want to keep track of your status of your package. Okay, and the other very important reason could be when you have a shipment or a package that has to be given a proper handling, such as if it can contain an item that is a breakable. So in such case, you have to make sure that your package is being handled carefully. And uh, so in such case, you really need an application like this. Okay, so this is how this project may help you in this by keeping track of your package or shipment. So how does this project work? So this project is basically based on Internet of Things, and I think you all have heard about Internet of Things. It allows us to connect all of our physical devices to the internet and get the information from those devices. But this project has a special part also. So it is not only based on Internet of Things, but it also uses artificial intelligence. So as we have used the TinyML model built with the Neuton.AI platform. So therefore, this project is based on Internet of Things and artificial intelligence. And how does this project work? So the shipment or the package that you have seen, so this contains the processor or microcontroller unit equipped with these sensors. So I'm going to discuss what kind of sensors I have used. So I'm going to discuss in the coming slides also. So the shipment or your package which is in transit uses a microcontroller unit. Okay, so right now we have different microcontrollers for this project we need to design a very compact and low cost microcontroller that can be used. So currently I have used ready to use microcontroller unit for this project. So the package or shipment is equipped with those microcontroller devices, and it transmit the information to the server over the internet. And because the information is loaded on the cloud server over the internet, you can easily extract or retrieve the information via the web application, which is also developed as the part of this project. Okay, so this is a very basic architecture for this project. The shipment or the package, which is acting as a sensor node, sends the information to the cloud server, and that information is retrieved via the web application. So how does this internally work? That also we are going to discuss in the coming slides. So the requirement to build this project, so there are two requirements, hardware requirements and software requirements. So for the hardware, you need a microcontroller unit. And for sensors, I have used accelerometer and gyroscope. For communication, I have used Wi-Fi, but you can use any communication medium. But for these kind of project, the most preferred way of communication uh, is GSM or NB-IoT or long range, that is known as LoRa, because GSM is also quite costly, so we cannot use GSM, but you can try out with that also. But NB-IoT and LoRa are the most preferred communication medium that can be used for these kind of projects. So NB-IoT is still at its very early stage in India, as there are very few vendors which provide this type of network, but I think LoRa can be used. So, but for this project, currently I have used Wi-Fi. And the software requirements are you need to have uh, an account on Neuton platform, and you also require Arduino IDE, and you can choose any uh, code editor such as Visual Studio or Sublime or any other code editor. You can even, if you do not have the Visual Studio or other code editor, so you can use Notepad also. So particularly we require this to create the web app. And you also need a MQTT broker. Okay, so here I will be using, I have used the MQTT protocol for the communication. So now the question comes, which MCU should you use? So there are different microcontroller units which are available in the market. You can use any of them, because the best thing with Neuton platform is that it gives you a TinyML model uh, that requires a very low space. Okay, so I have mentioned few of them. So you can use uh, AWS IoT EDU kit. So this is basically based on the M5 stack. So you can search their website. You can get all the information. So currently for my project, I have used this device because this device is available with me. And you can also use the Arduino Nano 33 BLE Sense board. This is also uh, a very efficient microcontroller that you can use for your TinyML project. And this is the Arduino Pro board, which has the capability to execute the machine learning algorithms. And if you do not, so these two boards which I have mentioned are basically a little costly, but if you really have a budget constraint, so you can also use Arduino Uno R3. Okay, but with this board you require additional sensor units and communication module, uh, whereas with these two boards it is already built in, such as with this M5 stack, we already have built-in Wi-Fi and Bluetooth, and with this Arduino Nano also we have the Bluetooth built-in that we can use to transfer data. Okay, so for my project I have used M5 stack. So here are some of the specification about this. So this is ESP32 based microcontroller board, which has built-in Wi-Fi, and it has quite uh, uh, a good flash memory and RAM, and it also has built-in uh, accelerometer and gyroscope, and which are available as the IMU unit. So IMU is the in inertial measurement unit, which is a device that typically consists of gyroscope and accelerometer. So this board has this built in, and this board also has a battery connected to it, 500 mAh battery, which is inside this board. So I have used this board for my project. Okay, so this, as I have already told you, that this board consists of 6-axis IMO unit. So 6-axis means it has 3-axis accelerometer and 3-axis gyroscope. So using which you can calculate tilt angle and the acceleration acceleration in the real time. Okay, so why I have used accelerometer and the gyroscope? So using the accelerometer you can measure linear acceleration, and using gyroscope we can measure orientation. So for our project, so you have seen one use case which is moving while the shipment is moving. So that information we can get through the accelerometer, and you have also seen one status of the package in which the package is uh, placed in wrong position, that you can achieve using the gyroscope. Okay, so the accelerometer and gyroscope, the other application that I would like to explain you about the accelerometer and gyroscope is that uh, uh, in some of the laptops, to protect hard drives from damage, the while the laptop is suddenly drops, the accelerometer is used to detect a free fall whenever a laptop is falling, and it can turn off the hard drive automatically to avoid the hitting of reading heads of the hard drive platters. And similarly, gyroscope, the other application of gyroscope that can be used is to measure the rate of rotation, which helps keep the drone balanced. So you can see drone fly, but how the drone maintain the balance is by using the gyroscope. Okay, so these are the other application of the gyroscope. So both the accelerometer and the gyroscope can be used individually, but when you combine the gyroscope and the accelerometer in one application, so you can both you can sense both the tracking movement as well as the rotation. Okay, so that is why for my project I have used both of these sensors. So I have also used MQTT protocol. So MQTT basically stands for Message Queuing Telemetry Transport Protocol. So MQTT basically the protocol which was first created for machine to machine communication or M2M communication. And now, since it is a very lightweight protocol, it is also used in the Internet of Things. And it is one of the most useful and used popular protocol when you design the Internet of Things application. So this is one of the most used and popular protocol. So MQTT protocol is based on publish and subscribe architecture. So you might all heard about the HTTP protocol that we use in our daily life while we are browsing the internet. So HTTP protocol, we all know that it is based on request and response. Okay, so whenever you request some website, in response, you get data from those websites. In the same way, MQTT protocol is the publish and subscribe protocol. So within the MQTT protocol, there are three entities. First one, there are basic two entities, MQTT known as MQTT client and MQTT broker. So MQTT are client which can either subscribe a message or it can uh, it can uh, publish a message. Okay, so the client which is sending some message or information is known as the uh, MQTT publisher, and the client which is receiving that message published by the publisher is known as subscriber. Okay, and between that the MQTT broker comes into the picture. So MQTT broker here, you can think of it as a little server application. Okay, so it receives the information from the publisher and make that information available to the subscriber. And how does this happen? It happens through a channel, and that channel is known as MQTT topic. Okay, so the topic is nothing but it is a name or an identifier that both the publisher and the subscriber uses. So we are going to see that also in our code. So this is how the MQTT protocol works, and there could be any number of MQTT publishers and any number of MQTT subscribers. Okay, and one or more publisher can publish on different topics, or they can share single topic also. So in our project, we have also used TinyML. So TinyML, you might already heard about the TinyML. So TinyML is basically the field of machine learning and embedded system, which allows you to create machine learning models that can be executed on resource constrained devices, which does not have a lot of compute power. So the TinyML model can be executed on such kind of devices. Okay, so this is also uh, these the microcontrollers which are capable of executing TinyML model are also known as intelligent edge devices. So why? What is the advantage of the TinyML? So it has the low latency because the model executed on the edge devices. So there is no need to send the data on the cloud server for inferencing. Okay. So, so if you do not use TinyML model, so you have to send data to the cloud server for analysis, for executing the model, and the result could be returned to your back to your device. But that could uh, increases latency. So to reduce that, we can use the TinyML model. So the machine learning model is executed on the edge device itself, and there is no need to send data to the cloud server and get data back from the server. So why it is important? The latency, why latency is important? So for example, let's say if you are designing a self-driving car. So self-driving car, we all know that must take decision in the real time. Okay. So in such case, if you do not use TinyML model, so your car must send data to the cloud server and then get back the result. So uh, in that case, your car will not be able to take decision uh, very quickly in less amount of time. And if the connectivity failure occurs, then you can have very uh, you can run into a problem. Okay, so for that we need to have the TinyML for such kind of project. So in the coming future, in the near future, we are going to see all these kind of devices that are intelligent devices and are capable of taking decision in the real time. So for that, TinyML is very useful. And TinyML is also low power consumption. It consumes very little power because why it consumes very little power? Because the TinyML model requires very less amount of memory and compute power. Okay, so therefore they also do not require uh, a lot of power, and it also has a low bandwidth. So because we are sending only the data which is the result of our inference, such as the decision. So we do not have to send a huge amount of data because the decision has already made on the machine itself, the edge device itself. So therefore we do not require large bandwidth to transmit data. So for example, if you are creating a security camera, right? So using this security camera, you have to detect a certain intrusion or any activity, such as whether the forest has caught fire. So you can capture the image, make decision on the device itself, and only send data whether the forest has caught fire or not. Okay, not the whole image data. So that require a very low bandwidth. So that is why when you develop applications using TinyML, so you do not have uh, very high bandwidth. You can do it in very low bandwidth, and you can use uh, uh, network like narrowband Internet of Things or LoRa network, etc. And TinyML model also increases privacy because the model is running on the edge itself, and your data is your data will only remain on the device itself, and you just send some alert or those kind of data to the server. So your all data remains on the device itself. So this also has the privacy feature. So let us now discuss the TinyML workflow using the TensorFlow. And the TensorFlow, you might all heard about it, developed by the Google. And TensorFlow is also allow you to create the uh, TinyML models. Okay, so here I'm going to discuss how you can, the workflow, how you can use TensorFlow to build the TinyML. And the diagram which I have, which you are seeing in this slide, is taken from a very popular book, TinyML cookbook. So you can also go through some of the projects which are proposed in this book, and you can try out those projects also. It's a very informative book, and it's a very good for those who really wanted to build their career in the TinyML. So here is the workflow. So whenever we are building a machine learning model, so we have to remember that the data is fairly important. Data is the everything. Data is very important. Okay, so first you need to capture the data, and then using that data we create the training and the test data set. Okay, then using the TensorFlow we design our model, and then we using the using the training data we train our model, and then using the test data we can test our model whether it is working perfectly or not. After the model has been developed, so this model is still uh, in a shape which cannot be fit on the microcontroller. So for that we have to convert this model uh, into the uh, microcontroller compatible model. So that is that can be done using the quantization. Okay, so we have to quantize the model so that it can fit as per the need of the microcontroller device. And after that we can take the quantized model and develop the application for the microcontroller. So developing application here means we have the quantized model, and we can create some other code, such as how the microcontroller will get the data from the sensor, and how the microcontroller can send data to the server. So that code, that part of your code will be combined with the quantized model, and then you can create the whole perfect TinyML application, and you can embed that application in the microcontroller. Okay, so the TinyML workflow using the TensorFlow, we can divide it into two parts: ML space and the embedded space. So as you can see that there are number of steps which are involved, and also the model which you develop using the uh, TensorFlow is not that smaller, which we get using the Neuton TinyML platform. So now I'm going to discuss what will be the workflow using the Neuton TinyML platform. So you need to have the data and prepare that data as the training data and the test data, and then use the Neuton TinyML platform. And this Neuton TinyML platform automatically builds the machine learning model for you, and it all automatically converts the model as per the need of the microcontroller. So while using the Neuton TinyML platform, you do not have to go through the steps of designing the model, training the model, quantizing the model. Okay, everything is done for you with the help of the Neuton TinyML platform. So Neuton TinyML platform does it all for you. It automatically builds the model for you, and it builds the model in very less time. And this model is also relatively quite smaller than the TensorFlow model. Okay, you do not require training, as I have already explained that you do not require training or quantization, and we can develop a 8-bit model, 16-bit model, 32-bit model, etc. And the model is developed, the TinyML model is developed, and it is also converted to in the form which can easily be embedded into the microcontroller. So you can simply get the model source code from the Neuton platform and build your application and upload it to the microcontroller. Okay, so for For my project, I have used 3 classes. Although in the video you have seen 5 classes, but here I'm going to explain you the 3 classes which I have used for my project. Okay, and the first class is the stationary. When the package is not moving, it is placed perfectly at some place. It is not moving, and it is also positioned in the proper way. So this is known as stationary. And when the package is moving, so I have used both the right and the left direction for training uh, uh, for training data. So this indicates that the model is moving. And the other class which I have used is the picked. So whenever you uh, pick the model, or after picking, whenever you place the model again, so it is counted as the picked state of the model. Okay, and also remember that I have given the numbers. So for stationary I have given 0, for moving I have given 1, for picked I have given 2. Okay, so let us now see how the data collection work. So for the data collection, I have used stationary, moving, and picked. So I'm going to show you how you can collect the data. So I already have a firmware. So let me upload this firmware. So while it is uploading, I'll explain you the code. So I'm using M5 core in the Arduino IDE. I think the code is visible. So I'm using M5 uh, uh, stack. So here is the library that you require. So you have to install the library before you can use this board. And then I have created 6 variables of floating type. So 3 variables for the accelerometer data and 3 variables for the gyroscope, as both has the x, y, and z axis. Okay, and I have also created one variable times and initialize it with 0. And then I have initialized the M5 stack, and M5 stack also has the built-in LCD. Okay. So as you see in the diagram, it also has the LCD on which you can display some data. Okay, so therefore I am also printing some data on some information on the LCD. So for that I have set the color mode. So the background screen is black and the foreground, the text will be displayed in green, and also fix the text size. Although it is not required, but since I am using this device, so I have used this. Okay. Then, so in the Arduino code, for the first you have 2 functions, setup and the loop function. So whatever you write in the setup function will be executed only once when the device is initialized, and whatever you write in the loop is executed repeatedly. Okay, so this works as the looping. So it execute repeatedly until your device is switched on. So everything you write within the loop function, it executes repeatedly. So here first, because the this M5 stack has the IMU built in, so and it also provides you the interface, so you can access the IMU's gyroscope data by calling the IMU.getGyroData, and you can access the accelerometer data by calling the function getAccel_data. Okay, and for storing the data, so I have already declared these variables. So all the data which is fetched by the gyroscope and the accelerometer will be stored in these variables. Okay, so I am printing the information about this variable on the screen. Okay, so I have provided the delay of 20 seconds and uh, increment the times variable by 20. So the total rows of data which we can get is around 501 rows. containing of this accelerometer as well as the gyroscope data. Okay, and I'm printing it on my LCD of the device as well as on the serial terminal. Okay. So the this information is already stored. So maybe you can see it. I hope this visible device is visible. Can anyone please confirm? Yeah, you can see this. So
Yes,
you can see, yeah, you can see some data is also printing on this LCD. So this data is basically in the top row, the data is about accelerometer, and in the bottom row, the data is about gyroscope. So this is on the screen. So I have just printed for the debugging purpose so that I can make sure that while collecting data, I can also see on the screen, although we are getting fetching data from the Arduino terminal. Okay. So let me open the terminal for you. You can say that the serial monitor. So when I open this, so right now you cannot see. So I just restart the device, and right now I am placing my node, the sensor node in this position. So this means that the stationary. Okay, so let me restart the device, and you can see that you get the data. Okay, so it automatically gets the data for you, and this data is for the class uh, called as stationary. Okay, so the data is finished. So I wanted to get the uh, some fixed amount of data for each of these. Okay, so basically what I have done is I have collected the accelerometer and gyroscope data for this project, and let's say for the stationary class. So I have collected the 12 samples, total of 12 samples, and where each sample has the 501 rows. So here you can see that these are all the 501 rows. Okay, it means that it is the 10 second of data. So this data is for 10 second. The whole data is for 10 second, and with the delay of 20 millisecond. Okay, so this data is the delay of 20 millisecond for the 10 seconds. So if you calculate, you can get 501 rows of data. Okay. So now how you can store this data. So one very simple way is that you just select from here, scroll down a bit, and select till here. Copy this, open a text file, any text file, and paste this data and save it as. So I'm going to give it a label, stationary one. So this is the uh, one file, and similarly I have collected data in the 12 files and rename it as CSV, comma separated values. I'm going to store it at the desktop. So this data is stored. So you can see the data. I'll show you how it looks. So it will, when you open the CSV file, so it is open in the uh, Excel. So you can see that now you get the data, and this data is for the stationary label. So like this, I have collected data. So as you can see, let me show you. So for stationary, I have collected such data 12 times. For moving also, I have collected data 12 times, out of which for training, I have used 9, and for test data, I have used 3. Okay. Later on, we all have to combine all these data. So I'll show you how you can do that also. Okay, so this is the one way, the simplest way that you can use to collect the data. You can also do one thing. If you have a PuTTY terminal, so you can open that also, and you need to select the serial and select the port. So I have the COM port 10 for my device. So you can select the COM port 10. Okay, and you can go to the logging, and here you can specify stationary 1.csv. Okay, and then you can open the terminal. So it will open this bin. Right now this will not create a file because I do not have the right permission on the system. So but this will open the terminal, and you can see the data uh, on the terminal, the similar in the similar way. Okay, so this is how I have collected the data. So I can also collect data again. So let's say now I am collecting data for the moving. So I can reset the device. First I clear the output. First I clear the output. Just a second. Let it complete. Okay. First I clear the output. I reset the device and then start moving the device. Okay. So this will give you, you can see the change in the uh, axis from the accelerometer as well as the gyroscope. Okay, so you can keep on moving until until it finishes recording the data. So this data is for the moving label. Okay, so now the data recording is finished. So you can again collect this data. You can collect this, copy this data. Okay, open the notepad, and you can save it as moving all files. So this will be saved as the CSV. So this is how we can collect the data. So like this, I have collected the data for all the labels. Okay, and then after you finish collecting the data, you have to prepare data in this way. Okay, so you have to combine the data for each of the label, and then you have to specify one more column that is known as the target column. Okay, so as the first row in our final document, we have to prepare the first row with the heading for the accelerometer and the gyroscope, and remember to give the similar name which you use in the code, so it will be uh, easier for you to understand as well. Okay. So how you can come now, you have a lot number of files. Okay, and it is not easy for you to open each file, copy the data and paste into the other file. So what you can do is you can use the online tool merge CSV. Okay, you can select the CSV file. So let's say I'm going to select the CSV files for stationery. So I select from 1 to 9. Okay, so all the files are selected here. Now you can click on merge file, and it is merged, and you can download the CSV file. So the file will be downloaded, and now you can see that the all the data from all the 9 file is merged. Okay, So, and now this is for stationary. For stationary uh, class, we have used the number 0. So what you have to do is you just write 0 here in the first row, and copy it till the last row. And then from here you can select all the rows, copy it, and like this you have to create a final file which you see very similar to our training data source. Okay, this one. Okay, so it has the heading, and this it has the label, it has the data for the stationary, and after that it has the data for moving, and after that it has the data for the picked state. Okay, so in this way you have to combine the data. So you have to make the data set in this format. Okay, so now you can use this data set to build the TinyML model. So now I'm going to show you how you can build the TinyML model. So we have collected our data, we have prepared our data set. Now we are going to use this data set to create the TinyML model. Okay. So first I'll show you how you can open. So you need to sign into Neuton platform. If you haven't created account yet, so it's very easy and requires very few clicks to create the account. So you can create the account. I'm going to sign up with the account. I use my Gmail address. Okay, so this account will be created, and you also have to subscribe to zero gravity plan, because because by default you cannot uh, load your own data while creating the solution. Okay, so for that you need to subscribe to zero gravity plan. You can contact Neuton team. They are very supportive and they help you to um, get subscribed to this zero gravity plan, and you do not require to pay anything for it. Okay, so now we'll see how we can create a solution. So in order to create solution, if you have created any other solution, so you can see all the solutions here. I have created different version of the same project also and other projects also. So you can create the solution by clicking on add new solution. Give name to your solution. So I'm just going to give a name as shipment demo. Click on next. Okay, and when you click on next, so here you get the screen to upload the data. So if you are uh, registered for the zero gravity plan, so you can upload your CSV file. So here we need to upload our CSV file. So I am going to upload my training data, which is the final data. Okay, so I'm going to use this data which has the 3 classes. So you open this, you get your data uploaded. So if there are naming constraints, so Neuton platform automatically rename your file, so you don't have to worry about it. So now my data is uploaded. If you have previously uploaded data, so you can see all other data which has been uploaded, but I am using this new one. Okay, after your data set is uploaded, you click on OK. And here we have to choose our target variable. So I have given the name as the target. You can give any name, but you have to remember that which is your target variable. So here my target variable is the status of my shipment. Okay, so I have chosen the target here. the other fields also you can see. And after selecting your target variable, click on next. Okay, I have given the name target to my field. You can also give it name such as uh, status. So here now you have to specify task type. So I am doing multi classification because I have more than one classes, and I want to classify uh, uh, those classes. Okay, metric you can select is accurate, and you have to enable the TinyML. Okay, because we are building this uh, model for the microcontroller, so you have to enable the TinyML. If it is by default disabled, so you have to enable it. And after that, our input data is float 32 type, so you have to keep this selected. And you also have to enable digital signal processing, because because our device or our model is getting or fed data from the real sensors. Okay, so that is why you have to enable this digital signal processing. Okay, and uh, there is one more option that you need to select is the window size. So window size should be auto selection. Okay, we do not know how much data our sensor can collect, or how much time we need to specify uh, uh, to feed the sensor data to the model. So we select the window size as auto. And after all these features are selected, so you can now click on start training. Okay, all these steps are also given here. So here the training is started, and in a very short time you can see the result, and the training will be completed for you. Okay, so if you want, so you can specify your number also. You can get the text on your phone as soon as the training is finished. So I'll just click on no. Okay. So while this training is going on, let me open the another code for you that we are going to use next. So first we have seen how we can use the how we can collect the data. Now we are going to test our data on the uh, microcontroller itself. Okay, so I'm going to open this code. Okay, so remember to create one folder in the same name uh, which your sketch has. Okay, so this is the requirement for the Arduino. Your sketch must be loaded in the directory which has the same name as of your sketch. Okay, so that is why the name of the folder and the name of my sketch or the source file is same. And then you also have to create one more folder inside it, that is known as src. Okay, right now this folder is empty, so you have to create uh, one subfolder within it. Okay, so here the model is downloading. So I have already, sorry, the model is being trained. So maybe I can use the other code from the model which I have previously created. So this is the same project. So I'm going to click on this. So once your model is trained, you will get screen something like this. So you will get all the information, and you will also get the accuracy. So right now, for my model, I got the 100% accuracy because I have collected the proper data, and there is no anomaly in my data. Okay. So while collecting your data, you have to be very careful, because if you fed correct data to your model, then you will get uh, relatively higher accuracy. So if you get 100% accuracy, it means that your data is quite good. Okay. So when the training is completed, you will get a screen like this. You can go through all the information. Neuton has a very good interface, so you can see all the analytics about uh, your model. Okay, you can see the confusion matrix as well. So on the right hand side, you can also see a C library, and from here you can download it. Okay. So because the Newton model, as we have learned in the previous slides, that the Newton platform takes your data, automatically design the neural network, train your network or model, and then quantize your model. So this is the quantized model. So we simply have to download it. Okay, so this is downloaded multiple times, and now we can simply use it in our project. So I have downloaded it. I'm just going to delete these two files. So this is my model. So I'm just going to extract it. Okay, so this is extracted, and you can see all the files here. So what you have to do is now you have to simply copy all the files from here and go to your project folder, the Arduino project. Okay, this is our project, and inside the SRC, just copy all those files. After copying, now we look at the source code. So this is our source code. So again, we have the similar six variables. You have to include your model. I have also included a string because I'm using this library. So you have to include your model. So I'm just explaining you the steps that is required to uh, build your application using the on the model that you have built. So include the header file, and then you can again collect the data from the IMU unit, the gyroscope data and the accelerometer data. All the data will be stored in the variables which we have created earlier, and then you have to create one array. So this is a float array, and within this you have to use all the variables which you have created, which stores your data. So basically this array will hold the real-time sensor data from the accelerometer and the gyroscope. And then we do not require this statement. Okay. Then you have to uh, use this code. Okay, so here we are getting the input from the TinyML model which the Newton has created, and this will get all the data until the buffer is full. So this will collect the data continuously, and once the buffer is full, uh, then this code will be executed. Okay, until the buffer is full. Okay, so uh, uh, here you can see that there are few other variables also. Okay, so we also do not need this because here I am calculating the time, so I do not require this code. Okay, so here again within this if statement, we have a nested if statement, and here we are you can see that we have called another function. So this will execute the model. Okay, this executes the model, and here we have provided the two variables, predicted class and the probabilities. Okay. So the predicted class will contain the real-time inference result, and it will contain the data from the classification, and we can check if the classification accuracy is greater than 60%. It means that uh, we have we have uh, we can choose only that particular class. Okay, so for example, if we have three classes, stationary, moving and picked, so the percentage of stationary is let's say 70%, and moving is 10%, and another remaining percent for picked. So it means that the uh, it means that it will give you the predicted class as stationary. Okay, so we can print that, and I am also printing the same result on the uh, LCD screen uh, of my M5 stack. Okay, so right now, as you can see, that uh, my sensor node still executing the data collection uh, firmware. So now I'm going to upload the code, this code. So I click on this button. So it will not only compile, but it will also upload. So while it is uploading, I will check if there are some questions. Meanwhile, if you have any doubt, so you can type in the chat box. Okay, till then I'll discuss the model footprint from the uh, for the model which we got using the TinyML platform. So here you can see that we have compared the model created with the TinyML as well as the TensorFlow. So I have also used the TensorFlow Lite to create the model on the same data. So accuracy from both, we got the 100% accuracy since our data is perfect. And but the model size, you can see that the model which is created using Newton TinyML is relatively smaller than the TensorFlow. So this is in KB. So you can see that our model size is very less. Okay, and coefficient is also higher in the TensorFlow. And the RAM, the most main part is the RAM usage, inferencing time, and the flash usage. So you can see that the RAM, our model built with the Newton TinyML also requires a very less amount of RAM, and inferencing time is also very quick, and the flash usage is also 69. So in comparison, we can say that the model built with the Newton is 36 times smaller than the model which we have built with the TensorFlow Lite. Okay, and after we will test our firmware, then we will see how we can create the full-fledged application. Okay, so now the data has been uploaded to my board, and here you can see that right now it shows as the picked. Okay, if I move, although you cannot see, so let me move this. So it has to be placed in proper position. So I am moving this, and you can see the moving result. Okay, so this is how you can upload the data. And accuracy also you can see the accuracy also there, prediction accuracy. Okay, now we will see how we can use how we can build the firmware. So to build the smart shipment firmware, we require these libraries. So I have already used the M5 Core 2 library. Okay, and now we also need PubSub client, and we also need Newton TinyML model. So we Newton TinyML model we already have. Or you also need to have a PubSub client library. So this is the smart shipment application. I'm just going to open it and I'll show you the demo in real time. Okay, so for this we require few other libraries as well. So pub sub client and the Wi-Fi, because I'm connecting to the Wi-Fi. So this is the whole code. Okay, here we have to initialize the we have to initialize we have to create the variable to connect to the wireless hotspot, as well as to communicate with the MQTT server. Okay, so for my platform, I am using the free MQTT server, which is available for developer to use free of cost. Okay, this is the MQTT server known as the MQTT broker. Okay, so it also has the address, so you can use either the TCP port, or you can also use the WebSocket port. Okay, so WebSocket is required by the uh, web application, and TCP port is required for the uh, Arduino, the application built with the Arduino. Okay, so then we also need to specify the name of our device. Okay, so I have given it a name. You can give any name, and then the topic. Okay, so this is the status. So I have given name to my topic is as the status. So what is happening here is my MQTT client or the publisher, MQTT publisher, which is my Arduino. Okay, so let me upload this also on the board. Till then we are going to understand the architecture. Okay, so here is the overall project workflow. So first we have collected the shipment data using the data collection firmware. Okay, this is our first step, and we have prepared the training and the test data. Okay, and with the help of Neuton TinyML platform, we have uh, created the TinyML model using the training data that we have collected. Okay, and so this is the model building stage. Okay, so in this stage, after building the model, we have also developed the smart shipment firmware, okay, as our third step, and we have also created a web application as our fourth step. So first step is to collect data and prepare data, then create the TinyML model using the Neuton platform, then create the smart shipment firmware using the Arduino, and the web application using HTML, CSS, and JavaScript. Okay, then you need to upload that model to the microcontroller. Okay, and this is the model execution stage. Once the model is uploaded on the microcontroller, we can feed in real time data to the microcontroller. So the microcontroller here is acting as a sensor node, which publishes the inferencing result. So what is the inferencing result here is the status of the package, either stationary or moving or picked. So this publishes the data to the MQTT broker. Okay, and we have our web application which subscribe to that data. So here in the code, the status which I have seen, so it is giving me some error, because for this also we have to copy the model, same process. Okay, so here you see that the topic is status. So what is happening here? The microcontroller publishes the inferencing result on a variable on the MQTT broker known as the uh, MQTT topic. The name of that topic is status. So this microcontroller publishes the information on the status topic, and the web application get the message from that status topic. So in the both the application, here also you can see MQTT topic status, and in my client application also I have subscribed to the topic status. Okay, so the same topic should be there, then only the information will be displayed. Okay, so here the publisher is my sensor node, uh, which is attached to the shipment, and the subscriber is my web application, which gets the data from the status. And this web application continuously look for the value published in the status topic, and as soon as the new value is published on the status topic, the web application immediately displays that message or the value on its interface. Okay, so let the code upload. Okay, so after building the application, then we have to program the web app. Okay, so again I'm repeating this step. The first step is to collect the firmware, collect the data. So create the firmware for collecting the data, and you can collect the data and prepare the data set in the specified format. This is the format in which you have to collect the data. And then second step is to build or create the TinyML model using the Neuton platform. And the third step is to uh, program the shipment firmware, which we have done right now, or we are doing right now. I am uploading the shipment firmware after testing it. So you can also test it separately, but finally, while creating the final shipment firmware, so we need all these libraries. And the fourth step is to program your web app so that you can clearly see the information on the web application in the user-friendly form. Okay, so our model is uploaded. Okay, and here in this model, you can see the same output for the code. The same output is here. Okay, but let me open the web application. Okay, so I'll show you in the real time. So I'll open the web application. Okay, so you can see that right now my uh, package is placed, so you can see it. And when I pick it up, so you can see that it is now picked up. Okay, and when I move this, so you can see that it is moving. Again, stationary, then picked, moving. Stationary, picked, and moving. Okay, on the terminal also, if you open the terminal, so there also you can see the inferencing result. Okay, probability 2 means, so 0 means stationary, 2 means picked, and 1 it means uh, moving with the probability of 100%. Okay, so this is how you can use the Neuton TinyML platform to create a real world application, uh, application for the real world that can interact with your physical environment in the real time, and uh, you can get all the information that you require. Okay, so uh, this is all about my project, and thank you for joining this webinar. So at the final closing thought, which I want to share among you, that we all know that we are uh, moving towards a world in which we see the embedded devices all around us, and many of those devices are connected also, because in the earlier days of internet, uh, we have seen that we only had, in those earlier days, we only had computers connected to it. Then slowly, when the smartphones became popular, then we see not only the computers or the servers, but our smartphones are also connected. Now, in today's scenario, we see the not only the smartphone or the computers, but all other many other devices such as refrigerator or even your smartwatch. All things can be connected to the internet. Okay, and there are many other physical devices also connect to the internet, because we are now in the connected world, and these devices which are connected to the internet are growing day by day. Okay, and we also see many of the devices which can take decision for uh, for you, even some application which are built in our smartphone. Okay, allows our smartphone to take a decision. Okay, even you see many fitness watch, they can also give you uh, give you the decision based on some activity. Okay, so we are moving towards a world which is embedded, connected, and intelligent. So my question is that, are you ready for this world as a developer? Are you ready to contribute to this world and create new applications? Okay, so I have also started my journey as uh, the embedded programmer and in the Internet of Things. Uh, 5 6 years ago, but in those days we could only create the applications uh, that can simply measure or gather the data from the environment, but cannot perform any decision. So each time while creating those kind of application or those kind of devices, we always need to send data to the cloud server for decision making. But now with the help of tools like Neuton platform, we can create devices which can take decision on the spot, on the edge, in the real time. Okay, so uh, I encourage you all to try out this platform. It is very good platform, and you can create a very stunning applications using this platform. Thank you.
Thank you, Timothy. Thank you for this detailed project presentation. I think your question have already the answer, and I'm sure that all our students have this ability to create new solutions and to move our technology development globally and provide these new solutions, new real world solutions. Let's move to the Q&A. We have at least two questions here. First question that we got, what would it, I think, of course, it related to your project.
Okay.
What would it show if a package is stationary on the floor or if moving? Michael, yeah, you can see this question.
Okay, so it is a good question. So you are, if I'm understand it correctly, then you are asking if the package is placed on the vehicle while it is also moving, right? So in that case, this project shows that it is moving. Okay, because you see, while the package is in stationary, so none of the axes are moving. Okay, it is kept still. None of the axes are moving. But while it is in the on the vehicle transported from one location to another location, so you can see change either in the x or the y direction. I hope this clears the answer.
Yes, thank you. More questions, please. And meanwhile, you tap your questions in this chat. We have also, I think, let me check. In the chat, I saw one. Pranav is asking, can we receive the code used here?
Sure.
Mhm.
I can share the code to Neuton team, and then you can get in touch with the Neuton team if you want to try.
No, Timothy, I think it will be much more easy if you can share it in the channel, in the Slack
Okay,
channel.
directly I can share in the channel. Okay,
Yeah, yeah.
sure.
As I
Yeah,
said,
so this will be good. I'll share the code in the channel, and students can go through the code, and if they have any problem understanding it, so I and the Neuton team can help them understand
great, great.
it.
Okay, yeah, thank you, Pranav. More questions we got. Uh, uh, can you read them, Timothy, or you would like me to read for you? You can open question and Q&A.
Okay,
Yeah.
Q&A. Yes, I can read it.
Okay. Perfect.
Please mention some books to learn TinyML. Okay, so I think I have already mentioned one book in my presentation from which I have taken the diagram. Okay, so this book you can refer. This is good book, and there is another book also, and this book is uh, TinyML by Pete Warden. Okay, so you can also refer to this book. Okay, this is also a good book for TinyML, and any other books. So Yulia can also help
Yeah, actually,
any other.
guys, for in our Slack channel, in our community, in the general channel, you can scroll and you can see previous announcement about the events and also some articles done by our head of data science department, Alex Miller. I think maybe 1 month ago, he shared very fresh digest of books that he recommends for you guys. And you can see, I think it was like a digest of 5 best books about TinyML.
Yeah, yes.
I will share this link also in our channel, in our post group. But you are very welcome to explore the general channel and find more books and materials that will be very useful for you. Okay, I think we missed 1 or 2 questions.
Okay, I'll check. I think I can see only the two questions in the Q&A.
Yeah, but this one, I think the first one we didn't answer. Which are
Okay,
few,
which
yeah.
are the few preferable Arduino models which one should focus on while working on such project? Okay, so personally, I really recommend you use this Arduino Nano 33 PLE cells. And there are other Arduino boards also, so that you can use. So, but this is my one of my favorite board. It also an Arduino Pro board. So you can not only use this board for learning purpose, but you can also create professional industrial grade applications using this board.
Yeah, exactly.
And
And
there are there are other boards also. So Julia can also help you out.
yeah, of course. I think maybe you remember from previous presentation from yesterday that our platform is silicon agnostic, so you can use any microcontroller, any board you want.
Yes.
If we're talking about Arduino Pro, we are partners with Arduino Pro, with Arduino, and I think they is planning to get more conferences and tech talks. So if you would like to choose Arduino Pro, then I think we can support you with additional information and additional technical, support for your project. But you are very welcome to choose any board you have, any board you want to use for your project, and please just do it, just check it. I think there is no problem.
Yes.
You are absolutely free in this choice.
Yeah. Meanwhile, students can also explore Arduino MKR boards.
Mm-hmm.
Those
Yeah,
are also Arduino Pro boards. Okay, so
exactly.
I think Julia, we can share them the link. There
Yeah.
they can look out. So arduino.cc/pro.
Mm-hmm.
So they can use this link, and here they can find different boards which are good. So from here you can see, go to the hardware, and you can select different kinds of boards here. You can see. So there are some low cost board also, and very tiny boards also that student can choose. Okay, so as I mentioned, the BLE sense is also mentioned here.
Mm-hmm.
Okay, so although these boards are specially created for the machine learning based application, but as Julia mentioned, that Neuton does not require very uh, large memory or compute power, so you can use any board and you can execute the TinyML model even in the Arduino Uno board.
Yeah, exactly. And also, just an example, one of the latest project we've done, it was done with a Raspberry Pi Pico that cost €4,
Yes,
$4
yeah,
even.
it's
The
$4.
most cheapest more board, the smallest one, and you can also try with this, and it's totally compatible with the Newton models.
Yeah, but it is good for student to go with the development board which has built-in sensor, so that they do not need to attach additional external sensors, and they can focus more on the application, the machine learning application that they want to build.
Exactly, exactly. Now I'm going to share with you guys in chat one link on the Hackster where you can explore also different examples of the projects done with different hardware. Maybe you can also take some ideas for your personal project, for your new future project from them. So you're very welcome to explore it. Mhm. Timothy, I think this question, the last one, we didn't
Okay, I see.
answer. Yeah. Mhm.
Which are few of the preferable Arduino models? I think this we have just answered.
Yeah,
It is about,
exactly.
yeah,
Exactly.
it is about the board.
I have a question. Can I ask?
Yeah, of
Yes,
course.
yes, sure.
Yeah.
Yeah.
Of
So
course.
when it comes to hyperparameters and all, does Newton find the optimal hyperparameters automatically, or do we have a can we input some custom hyperparameters for training the model?
No, Newton does it automatically.
Yeah, it does automatically, and it's find the optimal parameters for, and the neural network grows neuron by neuron. So it's optimized already, and you don't need to make any settings for this. And you can get the final model in the optimal size and optimal accuracy.
Okay, one more. Like
Yeah.
your project. Okay, how much time do you think it will take to finally hit the market with that? I mean, from this stage.
Uh, Actually, basically, it depends upon the who is going to develop the sensing module for the packages. Okay, so that is the main question. Otherwise, uh, it is not that uh, difficult task to create the application, but the hardware part is the more important. So I think we need to think about it and work out, find some companies that can manufacture the board for us. So first we have to design, so uh, very low cost and reusable kind of. Maybe you can think of not going for the traditional packages that we usually use, but you can think of implementing this project first for the medical equipments,
Mm-hmm.
like the vaccine, uh, that the box in which the vaccine are carried. So whether they are being given proper care or not, and slowly we can grow this kind of use case in the real market. For
Uh,
products also, like uh, refrigerator and washing machines, the big equipments which are being transported. For those, we can think of first implementing this project.
Okay, thank you.
Yeah.
Thank you for the questions. Do we have more? I don't see. Um, anyway, guys, if you will come up with some questions, please don't hesitate to type them, to ask them in our Slack channel. So this is space for you to share knowledge, to share experience, ask questions, ask any support or help, because our main goal is to give you practical knowledge and to help you to build real world AI solutions in the easiest way, with a pipeline that doesn't require you too much time and efforts and skills. So please, I I ask you, be active, be proactive, because you have now a real good opportunity to learn from real good experts from the field. And the first, let's say, task or exercise for you will be to practice and to build the model by using data sets that we just shared in our Slack channel, data sets that have been collected by Timothy for his project. So you are absolutely free. If you have, if you want to understand how to collect data, please do it. You are very welcome. If you want to skip this stage and focus mostly on the embedding part, so you can use data sets that we upload, build the model on Newton, and try to embed it, and share your results, share your doubts or questions that we can help you with them. And of course, tomorrow we will see you in the last session, where we will share with you a new use case, one more different use case with a different approaches that you can study and be proactive, ask us questions, and see you tomorrow. If you have something more to add or to ask, be free. We have a couple of minutes for this.
Yes.
Yeah, Julia, can you share the recording a bit earlier this time because it was raining heavily here, so
What,
for 1 hour.
what,
So
what can you repeat again?
can you share the recording a bit earlier this time because people have been asking. It has been raining here, so people had some issues. So if you could share the recording today itself, it would be very nice.
Recordings.
Yeah.
Yeah, of course. We will upload records by tomorrow morning in our
Yeah.
Slack
Okay.
channel. Yeah. And of course, we will upload also the presentation of today's session. So everyone can go step by step and see everything and yeah, and repeat and do this experiment by their hands. Yeah.
Yeah. Thank you.
Okay, great. So thank you again so much. Thank you, Timothy, for this super detailed project presentation. Actually, I'm sure that your project have very big potential, and most probably we will see your project in production in a few months. Yeah. So thank you so much.
We
Thank you.
surely have to think of it.
Yeah, thank you so much, Nihel, Harap. Thank you, everyone who are with us, and see you tomorrow.